but I killed the browser.
Sounds good to me. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Jenny List.
This is episode 341. Qualcomm owns Arduino, steppers still dominate 3D printing, and Google controls your apps. This week in Hackaday News, we've got 2 bits of awesome news, 1 bit of sad news. Let's start off with awesome. First off, 2025 Hackaday Supercon Speakers Round 2 was announced on Tuesday. Go check that out. If you do not yet have your tickets for Supercon and you are able to make it over to Pasadena, California, the very, very beginning of November, you absolutely should. We'd love to see you. It's the one thing we do in person in North America per year. If you like Hackaday, you should come visit us.
Definitely envious. It's not an event I'm able to go to, sadly. I'll see you all, those of you who are coming to Berlin next spring.
That's why we have Hackaday Europe. Folks in Europe, don't feel left out. We've got Hackaday Europe coming. Also, conference news, if you are anywhere near Philadelphia, Jawncon is going on this weekend, and this is a significantly smaller local hacker/everything con. It looks like a lot of fun. Tom Nardi has been going basically since it started up and just loves it. It's got a lot of the it sounds like it has a lot of the early hacker conference vibe to it, where
those ones are always good.
Just people who love doing what they're doing, getting together. And so if you're anywhere near Philadelphia, go see what kind of John they got going on. And then on to the sad news. Robert Murray Smith, a prodigious, I guess he was a battery engineer, and then the last 10 years or so, he's made 2,400 videos about all sorts of interesting hacker topics. And he passed away. He actually took his life, which is very sad. I saw his last video where he said he was done with his video series and he wanted to quit on a high note. And I was like, wow, that's really great. He, quit while you're ahead. And then we turn around and it was much worse than that. And that makes me really sad. What I really liked about his videos is the way he would take topics that other people don't really tackle that much these days and present them in a super accessible way. Like one of the first ones I saw of his was battery technology, DIY battery stuff. And of course that's his field of study, but he was doing it in a way, especially with these old school batteries from the 1800s or whatever, he would cover them in a way that made it seem like you absolutely could make one given the stuff in your basement. And, of course you probably could. The question is, had you? And I think for most of us out there, the answer was no. I really, deep in my soul, I hope some of these people have. But, between that and odd mechanisms and other sort of wacky inventions, he really, brought it down to a level where an interested teenager could dig into something really cool and get something out of it. And I thought that was just super, super inspirational.
Certainly, it's probably a very British stereotype, the bloke in a shed with a big mug of tea who makes things.
Right?
Sadly, he, I guess, conformed to another stereotype, certainly in the UK, probably elsewhere too, of blokes of that era. And he's not that much older than I am, but certainly the people who grew up in the years around the middle of the 20th century were brought up to bottle everything in. And it's very, very easy. It's almost a trope to say, if you are suffering depression, you must tell everybody, seek help. But it's one of the most difficult things possible to do. And I'm very, very sad that he was unable to do it. As Tom said in his write-up, more than one Hackaday writer has been through the odd difficult time. And I felt for him. It's the sort of thing that I wish I'd known him and I wish I'd been able to help. But sadly I didn't. Well, he'll be sadly missed.
Indeed.
This is a journey into sound.
What's that sound?
What's that sound?
This week is a Guess the Sound week, so we have an absolutely brand new sound. Jenny's going to give it a listen. You at home are going to give it a listen and write in if you have any clue what it is. First, Jenny, go for it.
Okay, hang on. Gosh, what on earth could it be? It's obviously some kind of hand-operated thing. Doesn't sound like a mechanical, for instance, in the past we've had communication media, we've had cyclical-ish sort of sounds from astronomy and things like
Right,
that. That
right.
sounded like somebody who's operating a tool.
Good. Very good.
My gut feeling is that it's something to do with textiles, but it's not a sock knitting machine. I know what they sound like, and it's not a loom. I know what they sound like. So I'll be very curious to see what it is.
Very good. I'll tell you, it's neither of those. If you, our listeners, have an idea what it is, head on over to hackaday.com/podcast. Scroll down to What's That Sound. You'll find the form to fill in with your best guess, and we'll see who gets it right next week. It is the sound of someone.
Oh, okay. Interesting. Yes, I suppose it is actually thinking about it.
Well, then, without further ado, let's head on off to the hacks. And I'm not sure this one is a real hack, but I wanted to talk about it in depth, so I didn't throw it in the news section. Qualcomm introduces the Arduino Uno Q Linux-compatible SBC. And this is hot on the heels of the news that Qualcomm has acquired Arduino. And there's all sorts of business stories there. Is it going to be good for Arduino to be owned by a single chip manufacturer? Yeah. I don't think any company is going to be good for Arduino. That gives me the willies. But what I thought was really cool about this article is that Maya, who wrote it up, actually focused on the board itself, the Arduino Uno Q. And I don't know what this thing is. You should absolutely have a look at it. We've linked to it. You can also head on over to Arduino's website and read the docs. It is basically a single board computer with an STM32 chip on it in an Arduino Uno form factor. And so it's kind of like a Raspberry Pi without any of the plugs for all the peripherals you'd want to plug into it, which sounds like a pain in the butt. But it's also got a microcontroller on board for kind of doing the GPIO and the real-time handling. What's super interesting is that they've got some remote procedure calls for the Linux system on the single board computer and talking to the microcontroller. And so they may have some interesting software that they're working on to make the two talk to each other. Because at the end of the day, that's going to be the most frustrating thing to people who want to use this is how to get the Linux computer to talk to the microcontroller. We've seen boards like this before. Intel had the Curie board. The Arduino Yun was a board like this before. And they are just horrible failures. You've probably never heard of either of them. And that's because they kind of live and die on the software. So if they get this RPC layer right, it could be really neat. And if they don't, it's going to be just so super frustrating to use that nobody's going to use it. And then there's the form factor. It's an Arduino form factor on the top, and those are the pins that are connected to the STM chip. But then on the bottom, it's got a couple risers that do all of the normal Linux computer system on a chip type things like, talk to MIPI display or talk to a camera or whatever. But for that, they've got these non-standard 2x60 pin headers. And I don't think you can get any peripherals for those right now. I mean, you can certainly design some. And so then the question is, are we going to see people designing breakout boards for this thing or not to make it actually useful? And I have no clue on that. I mean, this really just it's a whole new thing. It came out of nowhere. Qualcomm has been very much into NDAs in the past, so everybody's like, oh, how open is this going to be? You can click around on their website. They've got a pinout for it, which actually probably is basically what you need. They've also got a schematic, but the schematic is, it says which pins on the system on a chip go to which of the headers. It's not really a schematic. They have a data sheet, but it's like 30 pages long. And so if you're used to the old school first Arduino Unos where it had an Atmega chip on it, those things have like a 300-page data sheet. And then when they switched up to like STM32 based boards, they have a data sheet and a user manual. And if you combine them together, it's like 400 or 500 pages worth of telling you how the deepest internals of the chips work. This is a Linux single board computer system on a chip. It's so damn complicated. if they were gonna give you a data sheet in that level of detail, it would be like 2,000 pages. And instead what you get is this 34-page, like, happy, glossy thing. So I don't know. So that's kind of weird. I don't know how to approach that. You should definitely read the comments on this one. A lot of people, I think, have put their fingers on these and other pain points. My favorite, I think, was Olaf, who summarized the difficulty of programming a Linux computer versus the simplicity of the original Arduino setup with the phrase, if you can drive an oil tanker, it should be easy to ride a bicycle. Yeah, is that what's going on here?
I look at this and Qualcomm stand at a crossroads, or a T-junction even. It could go so well in which they treat Arduino as a community of would-be developers using Qualcomm chips, that some of them, if they're students or whatever, when they go on to be engineers, they will specify Qualcomm chips, and they could support and nurture that community, and it could go so well. Or they could treat it as a marketing thing, and it could be the next Intel Edison. Now, you won't have heard of the Intel Edison unless you blinked. Intel decided they were going to get into the Arduino Star market with this really neat little module. Looked a bit like the ESP32 module's little can with a PCB. And they announced all sorts of wonderful things, and then it just fizzled out, and they canned it after a year or two. Depending on what Qualcomm's strategy is, depends which of those two paths it takes. If I were dispensing words to the wise on this one, I would remind Qualcomm that just like Raspberry Pi, Arduino is not a hardware company. Now, that might sound odd because they make hardware, but they're actually a software company because everybody makes hardware. I could actually design a single board computer. I suspect that many of you listeners could too. But what makes the single board computer special is the software that comes with it. In the case of the Arduino, it's the ecosystem surrounding the Arduino IDE and bootloaders for all the different microcontrollers that's available for. And in the case of Raspberry Pi, it's the fact that they've kept a Raspberry Pi OS up to date such that I can download a new operating system for something they made in 2012. If Qualcomm stroke Arduino managed to keep that level of support, and remember, they live or die by the software, this will probably be very successful. But if they just think, we need a few flashy boards for marketing purposes and we can forget about them after a couple of years, it will crash and burn. That's my view on it.
And I think it's worse than that, actually, for them. I fear that what they're trying to do is aim at this full-fledged computer design because, A, that's what their system on chips are good for. I mean, that's what Qualcomm knows. And B, because they think, AI at the edge is the new hotness or whatever, because that's what it is in industry. And I think what they're missing is kind of the reason for the success of the Arduino in the first place was that it was getting people to blink an LED. It was getting people to take their first simple steps into hobby electronics and into adding microcontrollers into simple projects that they could have running around their house and would be actually impactful in their daily lives and stuff. We've all got computers already. Do we really need more single board computers? And there's just a level of complexity there, a necessary level of complexity. Once you have an operating system and full-fledged computer that isn't there with microcontroller programming. And I think they're kind of really different things, and mashing the two up like they're doing is really great for the super advanced people. Like if I were doing a robotics project and I was gonna have a Raspberry Pi on it and then I was gonna have a microcontroller on it to handle the real-timey stuff, this board would be exactly what I would want, right? And if they can tightly integrate it together and if it works well, I mean, for that one project, it's super awesome. But I want to build a USB joystick out of something funny lying around my desk, it's overkill. So I don't know. I don't know if it follows in the Arduino Uno spirit. And I think that's kind of what's happened with a lot of their single board computer-like devices, like offerings too. So we'll see. It may just be it's too complicated. And it's also very much entering the Raspberry Pi niche, right? Like as soon as you start with a single board computer on there, everybody's going to say, oh, well, this is just like and it's priced about the same too. This is just like a Raspberry Pi. It is, but then it doesn't have any of the peripherals on it. Like you can't just plug a USB mouse into the thing. You can't just plug it into an HDMI screen, no matter which HDMI cables you got. We'll see. We'll see. It's an interesting device, and we'll see if they take the steps toward the community that I think they need to take.
How well it competes with Raspberry Pi depends on how much bang for the buck you get. Raspberry Pi make some pretty cool computers, as we all know, but their problem is that a fully tricked out Raspberry Pi 5 is well into three figures. It's lost that original, 25 quid for a Raspberry Pi and it runs Linux. How awesome. If the Arduino Qualcomm people can make a thing that does some of what a Raspberry Pi does for what a Raspberry Pi used to cost, they'll be onto a winner, I think. A friend of mine looked at the proper computer that runs Linux with a microcontroller to do the real time stuff and rather uncharitably said, "Oh, they've reinvented the beagle bone. I will leave you to discuss that."
Ooh, that cuts deep, but I think it's also correct. Qualcomm has officially said that they're going to continue letting Arduino be Arduino. That either happens or it doesn't. And again, it depends on how their corporate overlords view them and whether they give them a long leash or whether they decide to use it to market Qualcomm's gear. I think the temptation's just too strong for the big Q. No matter how this shakes out, I don't think Arduino has been the company Arduino for a long time anyway. Like when people say Arduino, I think a lot of them mean the software and the programming environment, and nobody means an actual blue board produced in Italy. In that sense, our community has nothing to be afraid of because all the software is open source. And even if they decide to keep expanding things with proprietary parts, which they may well, we could still fork it and take our ball and go home. And in some sense, almost all of the Arduino software infrastructure was built by the community. Certainly all the things in there that add the most value came from all y'all out there. And that they can't take away from you no matter what. So I think in that sense, there's no existential worries to the hacker scene.
So next up is similarly a more newsy story than a project hack. It's actually from last week, and it's the story of Google will be in time requiring developer registration for anything that runs on an Android phone. They're very careful to say that doesn't mean you can't sideload APKs, but if you sideload an APK, it has to be signed by a registered Google developer. It's obviously there playing the security card, but to those of us who run all sorts of open source software and things on our mobile phones, or those of us who simply want to be able to use our own hardware for the purpose that we want to use it rather than what its manufacturer or our carrier tells us we can, this is not a good move. Actually, quite a lot of people in our community are a little upset about this. There's F-Droid, the open source app store, published a news piece where they urged users of F-Droid to lobby their politicians to get this looked at from the point of view of competition, because it is an anti-competitive measure in that other people can't decide what runs on Google's operating system, in that if you're not sort of anointed with the holy Google oil, you can't be on another app store. And they very much have a point there. It's something that's been kind of looming for a while, that with two fairly locked down ecosystems in the mobile space, that in our community, certainly we would want to look further afield. There are plenty of open source and unlocked Android distributions, but they still have this problem that they are still Android under the skin. There are one or two other operating systems, Ubuntu Touch, or the sort of Yola Sailfishes and things like that of this world. Is Yola Sailfish still a thing? I may be slightly out of touch. But the fact is, there isn't an obvious choice for the hacker that wants to run open source software on their phone. Nothing that really fills that gap. As everybody says, you can't run your bank app on some random Linux box. It would be nice to see our community come together and start to produce more conventional Linux distros for major mobile phone platforms. I know you can't cover every single mobile phone because every manufacturer has different chipsets or different requirements inside. And unless you are that manufacturer, you often don't have access to whatever blobs are required to compile a kernel. But it would be possible, I'm sure, to support more than a few phones. And it's possible in a year or two's time, if this happens with Google, we will start to see more serious competition in open source mobile phone operating systems. I look forward to that. I look forward, in a way, to doing one or two Jenny's Daily Drivers tests on open source mobile phone operating systems. The main reason I haven't so far is none of the phones I have actually are supported by any of them, probably because I'm a cheapskate and I don't buy expensive phones. But that should be a direction that Hackaday looks at, just to bring you experience of what are these alternatives like.
I would say go pick yourself up a cheap used phone off of eBay. You can get a
Possibly,
$20
yeah.
phone that'll run essentially any of the free distributions these days and still works as a phone. Like,
Quite likely, yeah.
if you don't have to run something that's incredibly compute intensive or use tons of graphics, you can actually do very well with $20 in a used phone. But I say $20 in a used phone, and now it's going to cost you $25 to get a Google developer license to write apps for your own phone. So, boo. I will say the good news coming out of this update is that they are not blocking sideloading of apps through Android Desktop Bus. So if you plug it into your local computer and you run ADB, you can still run apps on it.
Okay.
The problem is that cuts out a large fraction of the people who won't do that because it's super inconvenient, right? Like that's going to limit unsigned apps to really only the kind of hardcore, and that's a shame. I think the real thing that I'm still worried about is that this will have some sort of discouraging effect on people who are writing open source software and contributing it to platforms like F-Droid and stuff. Like, is everybody who's contributed cool and useful software on F-Droid going to have to pony up $25, or else I can't download the next upgraded version of software I'm currently using? And the answer is probably yes to that. And I think that still really sucks. Maya does end the piece noting that they have a feedback form still open on this issue. If you want to give them feedback, you can give them mine too. I mean, it's less bad than it looked 2 weeks ago, and maybe if we're lucky and we keep pushing on them hard, Google will stand down. But I don't know if I have full hope in that yet. Finally, a hack from me. This is from Bluja, mesmerizing patterns from simple rules. Basically a software hack, and maybe it's a piece of art. It's fantastic explorations of particle behavior, in particular one family of algorithms, the ones that come from the slime molds, the Physarum mold algorithm. And he starts off looking at this one by Jeff Jones that makes some really pretty, like, tendril-like patterns all over the place. It almost looks like that kind of Voronoi tessellation, but a lot more organic. And he explains how it works, and I'd never known, so I was super happy to read this. You basically pretend you're putting a whole bunch of spores down that want to move in one direction. When they move, they leave a little bit of a slime trail behind them. As they move, they look forward and they look a little bit to the left and a little bit to the right, and preferentially move to the place where they've seen more slime trail. So if there's absolutely nothing ahead of them, they just go straight on. But as soon as they cross someone else's trail, they'll turn onto that. And if there are multiple trails or a stronger trail, they'll go in the stronger direction. And after you lay down millions of these mold particles, they make this fantastic system of kind of interweaving tendrils, and it looks absolutely eerily natural. And that's, of course, because it's kind of mimicking what nature does. The next level of sophistication on this is an algorithm by Sage Jensen called 36 points. And this is called 36 points because there are, well, you just drop a letter or number, and that's the 36, down on the grid. And where you drop it, it follows a different rule set. So it changes the sensor distance, that is how far ahead the little particle sees the nearest trail, or the angle it's looking at. So you can look over a wider angle or a thinner angle, or at what angle it's moving. So it's got a rotation vector it can throw in there, or how far it's going to move. So there are a bunch of different kind of behaviors of the particles that you can change based on where you are. And that's really cool too. 36 parameters is a lot to tweak. And I think in this case, Bluja doesn't tweak them all, but only a subset of them, maybe 14 or something. But just from this, you get things that look like stars or like ice crystals forming or like crazy space worms. I don't know what. You can get just points that kind of radiate out all sorts of other shapes other than this kind of classic fungus network looking things. And that was really cool. And then the last step is Bluja kind of riffs on this himself. And this is where it gets really cool. He adds in two things that make all the difference in the world. One is some color algorithms that give them, depending on how far they've moved and how much signal is under them, the different particles get different colors. And these just look absolutely fantastic. And then the other is he gives them a little bit of inertia. So instead of just, instantly stopping and making that turn onto the strongest path, they actually have some velocity and inertia, and they kind of have to swerve around it like a skidding car or something. That makes these fronts that otherwise would just be lines turn into things like wave fronts, cresting and crashing. And you absolutely have to watch some of those videos. That adds kind of a temporal dimension to the whole thing that really wasn't there before. And so then you throw in color and you throw in this, and then you throw in a couple other rule sets, and it goes from being something that's very, very simple. Like the rules for each particle are essentially very simple. I mean, there are many degrees of freedom here, but nothing that I haven't actually just explained in the past 5 minutes. Like it's all really simple in that sense, but gets these just phenomenally complicated, beautiful, natural-looking patterns out that, alternately look like waves lapping up on the shore or, stars or alien anatomy or, who knows what. And all of it evolving in real time. These are just absolutely fantastically beautiful graphics that come out of really simple algorithms. Like if you haven't played around with algorithmic art, you absolutely should.
The thing that I found particularly pretty about this was the way that it's all in 2D, of course, but the way that the patterns jump out in quite startling 3D. It looks like you're looking at a picture of a three-dimensional cell structure or something like that. And it's purely an illusion because it's generated in 2D. But all the images that the sample images, your eyes immediately see depth, even though the depth isn't there. That I was quite impressed with. Maybe I got this more than other people will because, as I've written about Hackaday in the past, I have a strabismus, which means I don't have hardware 3D. All my 3D is in software. So I'm probably more conditioned to see three-dimensional or a two-dimensional representation of a three-dimensional image than somebody who uses parallax. But I was still quite impressed with that.
No, you're quite right. They do look three-dimensional, and especially as they evolve over time, sometimes it looks like you're, zooming with a microscope through in depth through a slide. Like, it's very hard to convey. I keep using alien or, or natural as my reference points here because none of this looks like it's, pixely or computer generated in any way. It all looks so very organic, and it's really cool. And I guess I really love the way this post just kind of breaks down the simple rules. Like, if you think Conway's Game of Life is cool, you are absolutely 100% going to think that this is cool.
So for me, I found one from Icoso Labs, who looks into how easy it is to get your own custom LCDs or membrane keypads made. And the answer is it's surprisingly straightforward. It's obviously not something you can do for sort of $5 or something like that. But if you are making a project where you're making either it's a very expensive project or you're making enough of them that it's worthwhile spending a little bit of money, getting custom LCDs and membrane keypads made is not as expensive as you think. They go through a lot of all the sort of design and all the considerations you have to make. But what it comes down to is if you've got about $200 and are going to order a quantity of them, say 100 or so, you're ending up spending about $200 on the tooling and then a couple of dollars or $1 each, depending on the size of the thing, for the display or the keyboard itself, which actually isn't too bad if you've made stuff in reasonable numbers, particularly having had experience with people making event badges. You'll make event badges in anything from a few hundred to several thousand, at which point that cost per badge is actually quite small compared to what you can spend on a display. Now, I appreciate that the availability and ubiquity of small LCDs and even now OLEDs mean that why would you make a custom segmented LCD display? And the answer is yes, the OLED or the LCD is always going to be more impressive in what it can do. But then again, if you have a segmented LCD display, nothing screams high quality manufacturing more than a custom display rather than just the thing you bought off Ali. So I found this very interesting. I don't know if I will ever do it, but it was certainly a lot less money than I expected.
Yeah, it's really cool to see how you would do it too. So, even if I were going to make a conference badge, say 500, 600 of them, like for Supercon, I would never get a custom LCD made because I just don't know how to do it, right? And that's one of the cool things about this video is that I think it gives you a starting point anyway. And it does look like it's pretty easy. It's just, here are the SVGs you need to make. Here are the standards they need to adhere to. Here are the things they need to tell them. And it reminds me of the time before I had ordered my first printed circuit board. Like, if you've never gone through that whole procedure before, you don't know what Gerber files are. You don't know what it is you need to convey to a manufacturing house to get them to make a PCB for you. And these days, that's so common that, it's hard to remember a time when you didn't know how to get a PCB made. But I promise you, there are tons of people out there, and I'm sure you're listening to me in the audience going, I don't know, I've never gotten a PCB made, and that's cool. Like, there are tons of great tutorials about how to do that. This is something there aren't super many great tutorials for. Did Joey Castillo do custom LCDs? I think he did. In fact, I think he gave a talk for Remoticon about his experience with that. I should go dig that up too, because that's also really good in talking about this procedure. The point is that this seems like something that, only the big companies can do. But it is these days something that you also can learn to do if you want. Again, like Jenny said, you don't want to do it if you only need 3 LCDs. At that point, you gotta, get a graphical one and fake it. But if you've got more quantity than that, it might be worth designing your own thing. Will next year's SuperCon badge have custom segmented LCD?
There's something to be said for it.
Next and last up from me, a video by Thomas Sandladerer. You thought you were going to escape without me talking about 3D printing. Well, you're not. This is why stepper motors still dominate 3D printing. I thought this was a really cool video because, I don't know, I've been in the 3D printer game since way, 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 way back. And the question of why are we using stepper motors has always been there. Stepper motors have a very limited resolution, and that's both a blessing and a curse. It lets you take one step, or these days micro step, forward without having to close the loop and say, okay, now where's the print head? And that's made the control of these devices particularly easy. And ever since day one, like this question, why stepper motors? Why not brushed motors? Why not brushless DC motors? Why not something continuous instead of something steppy? Why not closed feedback loop? Has been there since day one. And it's fun to see this kind of revisited, every 3 years, 5 years along the history of 3D printers. And I think Thomas really hits all of the points here, which is control of the open loop stepper motor is just so simple.
Yes.
And the drivers for them have gotten so much better these days with 8-step, 16-step micro stepping and much better current management on the part of the drivers that it's almost moot whether you're using a stepper motor or a brushless DC motor. And in fact, he comes down to if you were driving a brushless DC motor, you would be using field-oriented control, which is basically you put feedback on the thing and then you use a computer algorithm to say how much you energize the different coils in it so that you can basically program the amount of torque at any given point. You can do that also with stepper motors. It's just harder because they have this kind of built-in cogging. If you've ever turned one with your hand, you've felt that, right? It goes click, click, click. And back in the old days when we were happy with 200 steps per turn resolution, we would drive them into these individual steps, and that nice reassuring detent would mean that it settles out where you want it to. But nobody's done that for 10 years. Nowadays, everybody's driving all the in-between steps, and at that point, the steps just get in the way. It just makes it harder for it to hold positions that are slightly off of that detent step. And that's his point, too, that going to a fully brushless DC motor, which doesn't have steps, would be great. And field-oriented controllers these days are a lot cheaper. The only trick there is, of course, you don't have steps. You need to know where the motor is. So you have to have an encoder on it to give you this closed-loop feedback to let you know how much to energize the coils. And why don't you do that? Because it costs kind of $7, $10 more per axis than it does if you just use a stepper motor. And that's the saddest thing I've ever heard, but I think it's the cold, dark reality of 3D printers these days, is that, you know, if that knocks $30 off of the bill of materials for your 3D printer and doesn't make it noticeably worse, then there's no incentive to switch away from stepper motors. And that's kind of his conclusion, is that we're still using steppers because steppers are probably good enough.
You immediately see servo motors coming into their own if you deal with any form of larger robotics. If you find yourself near a robot arm, not too near, I hope, if it's working, then you will notice that it has beefy DC servos on it, because the price versus performance versus ease of control mathematics work out far better in favor of DC servos on that size or that power of equipment. So it's not that there's no reason DC servos can be used or that they're not used in other applications that we see. It's just, as you say, bang for the buck. It doesn't make sense on a small desktop 3D printer. Yeah. Am I right in remembering one of the early MakerBots had a DC motor for something? Was it as part of its extruder, or am I imagining that?
Yeah, absolutely.
Was it the cupcake?
Bingo! My God,
Yeah.
the old cupcakes used to have a horribly large 12-volt geared DC motor on them to push the filament through. And it was not very precise.
No,
that thing had, the gear train had a whole bunch of inertia, and it would just keep feeding filament after you told it not to. And, you know, the whole thing. It was also heavy as a dog.
Yeah.
But back then, the bed moved in X and Y, and the print head only moved in Z, right? And so the thing just went up and down. So it didn't matter that it was heavy. Thomas actually covers the newer group of printers, the kind of Core XY set. Bamboo Labs printer is probably the poster child for this, where these days they are actually using brushless DC motors in the extruder control there, because putting an encoder in there actually helps. It's nice to not have the cogging of the stepper. The brushless DC motors, you can get smaller, lighter ones that have the same torque as a heavier stepper motor, so you save on weight. And if you have a fast-moving part that needs to move in both X and Y, minimizing the weight there means you minimize the weight of the gantry, which means you minimize the strength of the motors that need to sling the gantry around. And, you know, you get all of these knock-on effects that actually do make maybe using a closed-loop brushless DC motor the right thing to do on the extruder. And so that's the one exception. We do see non-stepper motors in extruders. And it's funny you mentioned the cupcake, because of course that's the polar opposite of that, right? Like that's this big, heavy, chunky thing, but it's because it didn't have to move around.
Oxford Hackspace, my first Hackerspace, they actually had a working cupcake. And it's actually quite unusual to find a cupcake that worked, because most of them were frustratingly never quite worked. And yes, I remember it had a ridiculously tiny build plate for such a relatively large machine, even though the machine isn't that large in the scheme of larger printers. But it did print, but it printed very badly.
By today's standards, they were pretty cool back in the day.
It was, I guess so, yeah.
In my hackerspace, we were comparing it to a Darwin, one of the first RepRap machines, and that was the square one that was all kind of acrylic bits bolted together with threaded rod, and that thing was horrible. Like, it was a bad mechanical design. It was worse in every way, and so the cupcake was a lot smaller, but because of that, just kind of more mechanically sound and actually worked a lot better. So that was actually a step forward. But compared to what we have today,
Exactly. I remember Oxhack's Cupcake actually being used far more to play music because it was incredibly noisy and did it really well. Playing the Imperial March on a cupcake was its stock in trade.
Yeah, putting them in a plywood box is like it's like the strings on a violin, right? Like the box
Yeah.
is there to make it sound louder.
Yeah.
The other thing I want to say before leaving this video is Thomas goes in the other direction, the less sophisticated direction, and looks at things like dot matrix printers.
Okay.
And they all use just regular brushed DC motors, but with an encoder. They'll have either those, black and white alternating strips in a strip that goes along with it, or they'll have the rotating equivalent of that. They'll have a disc with opto interrupter and black and white. They have almost no precision in the motor control. The motors are just like it's a DC motor. You turn it on and it goes. But they have good precision in locating where the print head is. And because you can spit out the ink very quickly, rapidly, and agilely, it doesn't matter that you can't control the movement of the print head very well as long as you know where it is. And that's also a neat point of reference when you're thinking about what motors to put in a printer. It's not the problem you have in a 3D printer. You can't control the start and stop of extruding plastic filament quite as quickly as you can just go splat, splat, splat with inkjets. So it's not the right model. But thinking about those two together tells you why we don't use brushed DC motors for 3D printers these days. I think really it's only the expense for why you don't use brushless / non-stepping motors in 3D printers. How many of you in the audience have built a Voron with brushless DC motors? Raise your hand. Because that would be a hella cool thing to do. And as long as you're spending $500-$600 getting all top of the line parts, you might as well shell out and get some cool motors to go with it. Even just for the bragging rights, I would do it.
The final hack from me comes from MIDI In, who is producing a range of synthesizers, and one in particular is the MIDI SID, which, as you might expect, takes a MIDI input and feeds a SID, or I believe more than one SID. That's the synthesizer chip as used in the Commodore 64, which is a very venerable and much respected chip. And what she found was that she had some customers were coming back and saying that their SIDs were out of tune. What she's actually using is she's not often using real SIDs because obviously very limited supply of those. So generally, if you're building something with a SID now, you will use an emulated SID. Now, the ARM SID has been around for a long time, as it might expect, using an ARM microcontroller. But there is another one that has come along, and she had tried some of her synthesizers using this other SID emulation. She looked into the problem and ended up going down a rabbit hole of Commodore 64 timing. The SID took a clock from the 64, whatever the system clock was, and from that it derived its notes. Obviously, American or Japanese or NTSC World 64s had a slightly different clock speed from PAL World 64s. And thus different SIDs had different tuning, effectively. And what had happened was that the ARM SID actually listened to the clock signal and tried to emulate from that, whereas the new SID, whatever she was using, had its own clock. And they were both good at being a SID, they just did it in a slightly different way. Now, the interesting thing for me was that the PAL computers, as sold in the UK, where I come from, or Germany, or the rest of Europe, they all had the PAL clock speed. But for some reason, Commodore thought, when we're selling this in the UK, we don't need to localize the manual. We just have an English manual in the United States. So British Commodore 64s were shipped with the US English manual, which of course had a table of all the notes and all the parameters you had to program your SID with, which were of course wrong. So all British programmed Commodore 64 music sounded off tune, apparently. I didn't realise that I don't have perfect pitch, and I don't remember feeling that everything was off tune in the 1980s when I played on the occasional 64, but that was a fascinating thing. Now, when I'm not writing for Hackaday, I have been known to do odd bits of documentation and other things for various different other places, software companies and stuff like that. And from time to time over my whole career in the publishing business, I have dealt with localization, which is where somebody translates something and you come in as an editor and you check over the English. And that's one that will now be added to my little store of localization anecdotes and things to watch out for. It's a very geeky professional thing from my point of view, but it was fascinating to read that. As to Midian, she has fixed the problem for her customers simply by giving a firmware update with an option to change the different timing modes, which is very good because ultimately she needs to be able to serve a product that sounds in tune for her customers.
That's wild. So that means that music written by Europeans on the C64 would sound different when played on American C64s and vice
Yes.
versa. And that means everybody is like, why do the Europeans listen to everything so fast? And they're like, why do the Americans listen to everything so slow and low? Maybe they're just more relaxed.
I think it was off tune more than
that's even worse.
off beat. But unfortunately, as I say, I'm not musical enough to probably notice the difference myself. So my apologies for that.
I mean, I think it's just a scalar multiplier, right? Like if it's just what's your clock speed, it's just one's going to be at 440A and the other's going to be at 430 something A.
Yeah.
It's only going to sound weird if you play it with other instruments. Yeah, there you go. That's the catch. If you play it with other instruments, which is exactly what she's doing here. Yeah. Very good.
It's a fascinating rabbit hole anyway.
That's really cool.
I never got to program a SID back in the day because I was in Sinclair world where, certainly for the earlier Sinclairs I had, the sound was spectacularly awful.
Oh, I was in color computer world. I hear you.
It's certainly, as a grown-up, it's been fascinating to learn about the design of the SID, its three voices and its different waveforms. If I had a Commodore 64, I'd actually love to have a go at programming for it. Really should borrow one from a friend of mine or use an emulator.
I was going to say, get yourself an emulated SID chip and you're off to the races. All right, my first quick hack is a musical hack from Brady Y. Lynn, a childhood dream created and open sourced. This is the story of the Stradex 1, which is kind of violin-esque as far as MIDI controllers go. It uses a long touch resistor soft pot to give you places to put your fretting fingers. I guess on a violin, you're just pushing the strings down, no frets. And actually on that topic, he's got a 16-bit ADC on it. So as Tyler August, who wrote this up, says, it's not that it doesn't have frets, it just has 2 to the 15 of them, which is so many frets, it almost doesn't have frets. Anyway, it's a really cool design. This one is got fantastic keys. It's a significant upgrade from his childhood dream version of this, which just had one tack switch per fret and was significantly less playable. This one looks a lot more playable. Next up, tips for C programming from Nick Barker is a video about how to get into C programming if you were doing it today. And he makes a bunch of interesting choices here. One, he says, stick to C99 when there have been 2 C standards since then, but they add things that might be complicating and confusing for the new player. C99's a little bit simpler in a bunch of ways. But that said, it's not super old C like you'd learn if you were reading Kernighan and Ritchie. It's got a lot of the kind of more modern features, and he goes into those, like defining values inside the structure and things like this. It's a really nice balanced take on how you would write kind of, quote, modern C without going to the most modernist of Cs that kind of take on newer extensions that I think to some people seem like more of a step in the C++ direction. Anyway, neat, fun video. If you are a seasoned C programmer, you'll be shouting at the screen or nodding your head, depending. And if you're a brand new programmer, I think it's probably an all right way to get started. Last up, degree of freedom. Finding simpler Schlieren imaging systems is a very cool break it down to the absolute minimum approach to building Schlieren setups. And he starts with just the sun and a candle and demonstrates that you can see the heat waves refracting light differently, even with just the sun outside and a piece of paper. but it depends on things like getting the heat source the right distance from the piece of paper. And it's kind of messed up by the sun not being a strictly point light source, but being a disk we all see in the sky. He improves on this with the point light source. He improves on this by getting the distance to the projected wall better. He improves on the brightness by throwing a lens into the apparatus. And then, of course, the razor blade, which he also demonstrates can be substituted out with a pinhole. Basically, the only point of this part is that when the light gets refracted one way by whatever hot air or whatever is in the way, it gets blocked by the razor blade, and pushed the other, it goes through. The razor blade also serves as kind of another pinhole lens in the middle to make the beam even tighter, which he then replaces actually with a pinhole, makes a 2-pinhole Schlieren setup, which gets him some super awesome results, although maybe a little bit darker than the traditional one. Anyway, really cool demo, and if you don't understand how Schlieren imaging works by the end of this, I can't help you.
For my quick hacks, first up is Grant Davis with a delightfully balmy construction, a working DVD logo screensaver with Lego. Now, if you're from the DVD era, you'll probably remember this. When your DVD player wasn't doing anything, a little DVD logo would bounce around the screen. These kind of screensavers, they were from the days of CRTs with phosphor screens. You didn't want anything to appear in just one place because it would burn itself into the phosphor. So you had things that moved around to try and even out the wear. And what he's done is he's made a DVD logo that moves around a Lego screen, but it does it on a mechanical XY mechanism, and it does it convincingly. It's delightfully balmy, and I absolutely love it. Next up is Nathan Ladwig, who has made an ESP32 decode SPDIF audio. We're probably all used to I2S audio, which is the serial CD quality audio format that you would find inside a piece of digital audio equipment, so internally inside your CD player or whatever. But SPDIF is a slightly different serial standard, which appears on the socket or in some cases on an infrared LED on the back for sort of fiber optic transmission. The ESP32 doesn't have an SPDIF peripheral, but I suppose this could come in our current competition in a way. It's a wonderful example of using a peripheral for something it wasn't meant to. The ESP32 has a remote control peripheral, which is designed to decode the 38 kilohertz infrared remote control signals, but it can be bent to the will of decoding SPDIF, which I was quite impressed by. I always like to find new and exciting ways to misuse bits of microcontrollers. Finally, we have Levi Kelly, which is something that's dear to my heart because I've always wanted one of these and never had one. He's converted a little K-truck into a tiny RV. If you're not familiar with K-trucks, it's a Japanese thing. It's a taxation standard for tiny little vehicles. It's intended for Japanese cities and the like. You pay low tax on these tiny little vehicles, very small engines and very small space on the road. And Japanese car makers have applied lots of interesting and innovative designs to make incredibly useful vehicles on these platforms. So you end up with these tiny little pickup trucks, which actually have comparable load beds to some monster American or European pickup trucks that are much bigger. And he's taken one of these and he's built a little RV box for the back of it. And he claims it's the smallest livable RV. It's got all the sort of toilet and sink and heater and shower and solar power and whatever else you can throw into it. Personally, I would have made it a fully functional hackerspace and workshop as well, but he hasn't. And I just looked at this and I like it. I want one. However, those of you who met me will know what's coming. I'm actually over 2 meters tall, so I wouldn't be able to sleep in it.
All right, well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week, I'd like to cover Dan Maloney's Ask Hackaday, Why is TTL 5 volts? I mean, 5-volt electronics has been 5-volt electronics, and a lot of us started off messing around with these things back when that was a reasonable standard. I mean, it's 3.3 volts now, but back in the day, it used to be 5 volts. Old school Arduino ran on 5 volts. TTL runs on 5 volts. but why 5 volts? And he went digging for answers. Kind of a red herring. He starts off by saying he asked ChatGPT and it gave him this answer. It's 5 volts because that's the standard. And it's like, oh, well, thanks. So it does not really answer the question. So he goes and digs into it and comes up with a couple plausible ideas, and I think that's about the best we're gonna get. This being an Ask Hackaday, part of the point here was to kick up a bunch of good plausible ideas and then see if anyone has any special information in the comments. And I have to say, I don't see anything that's particularly more authoritative than Dan's able to do it. I mean, Sylvania used to have one that was 5 volts. Nice round numbers. I'm getting down to the bottom of the comments, and here are more and more people saying they don't have them. I think basically the consensus is it could have been anything between kind of 3.5 volts and 6.5 volts. I mean, 6 volts is kind of an upper limit for transistors on a chip of those days because the transistors had a leakage current that increased as the voltage across them increased. And given the production techniques of the time, 6 volts was where it started to leak. And if you start pushing too much current through an ostensibly closed transistor, it wears it down and it's going to die. So 6 volts was kind of an upper limit. 6.3 volts was the standard for a lot of tube stuff because that was the voltage you'd get out of 3 batteries at the time. So that was kind of another reasonable number. They wanted these TTL chips to be kind of interoperable with tube stuff. So it wanted to be kind of at the upper end of the range. It couldn't be at the super low end of the range, again, because of transistors. And a lot of transistor amplifier designs and stuff need 2 transistors. So you need, 2 times the transistor, whatever it is, gate.
Base emitter drop.
Whatever. Yeah, see? I've been doing MOSFETs too long. Gate source. Base emitter drop. Thank you. So, yeah, point being, there was kind of a plausibly definable lower value and kind of a plausibly definable upper value. And anywhere in between, it could have fallen. A bunch of people point to a bunch of sources. I don't see anything that's super definitive as to why it was 5. I am tempted to say it's because it was the nice round number that was in the middle of that range. And they're just like, well, are we going to be jerks and make the standard around 4.7 volts? Or are we just going to round up to 5? And they did.
I delved into the history of 7.4 logic a few years ago. I did a little piece on the 7400 because we celebrate chips that have survived a long time, the 555, or people will talk about the 723 power supply chip or whatever. But actually, the 7400 is a survivor from the early 1960s. It came out about 1965, and it's obviously a very important chip because it spawned so much other logic. And it's an interesting thing, the first chip wasn't actually the 7400, it was actually the 5400. It was actually a chip for military applications. I'm just wondering, could there have been a military spec to it being 5 volts? Also, at the time, I believe there were other competing logic families that needed various different rails. I seem to remember there was one that needed a negative rail to make a reverse bias diode out of the substrate of the chip. Was that early CMOS? I'm sure there will be people in the comments come and tell me what it is. TTL was the one that won because it had such a simple power supply requirement.
I like your military theory there, that maybe that was...
It's only a guess.
But only a guess is all we've got. Dan does his research here, and he goes into the original TTL patent, and it doesn't mention the voltage level at all, because if you're writing a patent, you want to describe as broad a case as you can, right? So your patent applies to everything. And so it just talks about 2 voltages, B plus and B minus. Thank you. And it doesn't say how big the gap has to be between them. So, like, totally useless, right? So people pointed us off to the EEV blog, and I read through those, and there's no definitive answer. I think it's a stumper. And I like your theory that it could be a military standard. I'm going with it's just a round number in the plausible range. That's Elliot's answer. But so far, that's all we've got is folk wisdom and made-up wild-ass guesses. So if you actually do know, please head on over to the comments at Hackaday and let us know, especially if you have any kind of first source documents. We'd love to see them.
So it sounds like blowing your own trumpet to feature your own piece as the can't miss. But this week I produced the latest installment of a very long-running series, No Audio, where I delve into audio technology. And I must apologise because it's actually about 2 or 3 years ago I said I would come back with a second piece to talk in more detail about audio distortion, and then various life events got in the way and I never did it. So I came back and did it in the last couple of weeks. What it is a practical example of measuring distortion in an audio amplifier. So I've taken my elderly Hewlett-Packard distortion analyzer and applied it to a small tube headphone amplifier. If you're interested, it's one of those little cheap Chinese twin triode preamplifier kits modified with a pair of little transformers to make a not very good headphone amplifier. The article takes you through how to measure the distortion, but it also tells you how distortion is measured and how the instrument does it. The Hewlett-Packard it's actually probably the highest quality piece of test equipment I own, and I own quite a lot of pieces of test equipment. But this one's probably about the same age as I am, from the early 1970s. And it's a very high quality audio filter that can be tuned across the audio range, coupled to a suitably accurate RMS voltmeter. And the idea is that you feed it your audio signal through the amplifier you're measuring, and you first measure the voltage and you adjust it to a calibration level. So you adjust it to where the meter says 100% or whatever, and then you switch it over to a setting where the filter is in the circuit. And at that point, if you're supplying your amplifier with one frequency, in my case 1 kilohertz, because that's usually the frequency all these things are made, you can then use the filter to filter out that 1 kilohertz, and then you can measure what is left over. And the idea is that if you're supplying a perfect sine wave 1 kilohertz into the amplifier, then anything left over aside from 1 kilohertz will have been produced by nonlinearities in the amplifier. So you can measure the distortion by looking at what's left over after you've taken out the fundamental frequency. And that's what this does. And it allows you to switch the voltmeter down to a range where you can actually measure, it's usually a fraction of a percent, and come away with a distortion figure. Distortion is usually the sort of gold standard measurement by which hi-fi is judged. You know, the manufacturer will say, yes, this has a 0.00003% distortion figure, and you're supposed to go, wow, that's amazing. And of course, there's a little bit more to it than that. For a start, it's usually the figure quoted is usually the distortion at only one frequency. And it's quite easy to make an amplifier with very low distortion at one frequency. Making one that has no distortion across the whole range, in particular distortion in the phase domain rather than in the frequency domain. So if you imagine distortion in the phase domain is where the signal takes a different time to get through the amplifier at one frequency to what it does at the other, you can have a very good, on paper, distortion figure for 1 kilohertz, and in fact the amplifier doesn't sound that good. It's a figure that has its problems, but then again, if you make a straightforward amplifier that has a good figure at 1 kilohertz, it'll probably sound quite good at the other figures as well. Now, we had commenters saying, oh, if you make a flat amplifier, it doesn't sound good because you expect to hear all the harmonics. And to that, I would argue that what the harmonics you want to hear are the harmonics produced by the nonlinearities in the instruments themselves, rather than in your amplifier. If you listen to, I don't know, say a violin playing, a lot of what you're hearing isn't some pure sine wave produced by the spring. It's all sorts of weird and wonderful other frequencies produced by the fact that a violin is not a perfect audio oscillator. Over my time, I've done various work professionally in audio design, and I have at times listened to some very high-end audio kit. I'm not an audiophile. I'm actually interested in audio engineering. So I'm not blinded by, wow, this set of headphones cost me $6,000. But I will say that if you have an amplifier with a very flat response and a very good distortion figure, it certainly sounds very good. It has no harmonics kind of idea that some of the commenters were saying. Anyway, have a read of the article. Enough of me rabbiting on about it, and hopefully you'll come away knowing how to measure distortion in an amplifier. It's not actually the first time I've dealt with this thing. A few years ago, I did an April Fool where I made a fake gold cable, which I found to be far better than a standard USB cable. And I actually measured it, or sham measured it for the April Fool, using a distortion analyzer, using exactly this theory that I'd put together in GNU Radio. So if you page back through Hackaday, you should be able to find that and have a play with it yourself if you've got GNU Radio and a decent sound card.
That's awesome. I didn't know until reading this article how distortion measurement was done in my kind of naive modern brain. I assumed you just do Fourier transforms on things and see how much energy ends up in the other bins or something like that. And this is lovely. I just really love the idea of build a filter that's accurate enough so that you can throw out everything that's not 1 kilohertz and then see how much voltage you get out. Like, that's just so inside. It's just so raw and in your face a way to measure it. I'd love it.
If you want a single figure to quote, it's probably some audio engineer back in the mists of time did that. It's funny, audio engineers have probably given themselves a selective hole in their hearing at 1K by listening to it so much.
Beep. All right, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to follow along with the links, head on over to hackaday.com/podcast. And to send us news of anything cool you've seen, write us tips@hackaday.com. And until next week,
Eat, sleep, hack, repeat.
yeah, I only clapped 3 times.
Well, I tried to think of a pearl of wisdom and couldn't, so I'll remain silent.
That's really all I can think of to say. Take over with your rants if you want. I think I don't want to say this on the air.
I hope it has a wrencher key.
It does.
Yay!
Between Control and Alt.
Is it me or is it you? Oh, yes, MIDI. Hang on. Yes, let me restart this. Electrical. Where did that come from? Electrical.
Welcome back.